Last year in your textbook, you learned that for a parabola, that the formula, the standard formula was y equals a x minus h squared plus k. This time, and although that's a good one, this one is the vertex form because you get h and k out of it, and you can have the vertex and you can graph it with that because the a helps as well as you can plot some points. Perfectly good form. They are using this one, which gives you some of the same information, but helps a little bit in a different way because here you have 4 times a, and that'll actually use you. Because remember, some of the things like finding the focus points required that you added 1 over 4a or subtract 1 over 4a to get the directrix. Well, here you have 4a for you already, so it just is another way of showing it. And you would get the same thing if you subtract k here. And then, let's say, how is it? There's if you multiply this all out and work it out, then you end up with, getting virtually, oh, no, I wrote that wrong. It's 4p. Yeah, why did I put a? I put 4p. I guess I was stuck with my a here. So make that p, please, 4p. And what we'll be doing is using that to help us, and they have a certain way. There it is. It's like p. Let me go down here. Find the vertex. We're going to use this to find the vertex, and we're going to use it to find the focus point. Okay. And we're going to find the directrix, and then the latus rectum, and then we're going to graph it. So I should write up here first one that we're going to use. Let's use x plus 2 squared equals 4 y plus 1 squared. So set that up, and then let's use for the vertex of this, we're going to use the x and the y, -2 and -1. Oops. -1 first. It's there, -2, -1. Now for the focus point is going to be going up or down from this because we have it as, let's see, oops, and I correctly did this, so I put the square. I'm so used to putting squares here that I actually put one there. The x is the one that's squared. That means that our parabola is going to be going up or down. And so we're going to be going up or down. Since we have a positive here, that means we'll be going up parabola like that. That tells me I'll have -2, -1, and it tells me my focus point will be somewhere up here, and my directrix will be somewhere along there. So to find that focus point, that means we're going to be on the same axis of symmetry, but we have to do something with this. You had learned last year to use k plus 1 over 4a. Well, this is easier because that p here, what happens is that you can find what p is, and it's actually k plus p. So what we do is we take this number, and we do 4p is equal to 4, because here's the basic one, we make it equal to that, and then we divide by 4 and we find that p is 1. So we come over here and we do -1 plus 1, which means the focus point is 0. So our focus point is -2, 0. And this is actually a good time to actually start graphing, and I'm going to come down here and do a simple graph of it. Then if I go to -2 and -1, that looks like it would be there. My focus point, according to this, would be -2, 0. The directrix is going to be y equals the k. It used to be k minus 1 over 4a. Now it's going to be k minus p. And that means since it's 1, k is -1, and 1 is, p is 1, so we're going to get y equals -2. -2 is here. So do the directrix. And the latus rectum is 1, well, now that's an interesting one because that used to be 1 over a. That's what I had always learned it of. What they do here in a way is a little bit simpler. They do 4p. So if p is 1 and this is 4 times p, then actually 4 times 1 is 4. So the lattice rectum is 4. So I'm not going to use this one anymore, at least with your class. Integrated 3, because they're using a book that goes through it and does it this way, I'll keep using it with them. So I have to be careful and keep my mind straight as to who I'm with today. So for you, I'm going to use this. By the way, if you are used to what we did last year and you prefer doing it that way, perfectly fine, as long as any questions on the test that have this, you're going to have to translate it in your mind and use it the other way. Now, I don't care as long as you can get the graphing and your equations right, but I will. This is one way that might appeal to people anyway. So the lattice rectum is 4. That means that the length through the focus is going to be 4 lengths, for a distance of 4 units. So I can go 2 units on each side, and those are the ends of where the parabola is going to go. And it's a pretty nice wide open parabola, I guess, because many times the ones we've seen, the lattice rectum is a lot smaller, and therefore the parabola opens up as a much narrower one. Now it's a very wide one, because the longer that the lattice rectum is, the wider that the parabola will be. Okay, so what you've learned in the past with the conics is not going to hurt you for this. It's just you have to recognize that there is a different, a slightly, I guess you say different view of it on here. Okay, so let's review this here. I'm sorry this is messy, and hopefully I'll clean up the next one we do. Let's go back and we point out the things. Here's the basic form, and then what happens with it is if you have it there, you can say, okay, here's h, here's k, and 4p is equal to 4. Divide by the 4, I can find p is 1. The vertex is h and k. For the focus, I'm going to add p to it, to k. And for the directrix, I'm going to subtract p from k and get a line, the equation of a line. And for the last rectum, it'll be the absolute value of 4 times p, and that enables me to give an indication of where the parabola should go. Any questions about doing this? I want you to graph one. You can graph one next week. Okay. So now let's come over here next for the second part of this one, and let's complete the square to make the equation of a parabola. But this time I want you to make the equation in the terms that they're looking for, with x minus h squared equals 4p y minus k. So let's do it that way. Right, so that doesn't mean that much different for some of it. We're going to still have to complete the square, but all of this is going to go on the other side. So what we'll do is we'll take 8y plus 1 and move it to this side. So x squared plus 6x equals negative 8y minus 1. And we're doing that because our goal is going to be to get to this x minus h squared equals 4p 1 minus k. That's what we want it to look like. So it makes sense to put the y over here and keep the x's here, and just the x's to get the constant over here so we can complete the square. So 6 over 2 squared is 3 squared, which is 9. So I'm going to add 9, which means I'm going to subtract 9. Okay. Oh yeah, I'm going to add 9. Thanks. Just as you did there too. So here that's going to be x plus 3 squared. Now here I have negative 8 plus 8, or negative 8y plus 8. That tells me I can take those numbers out, because here in this case I do not want a coefficient in front of the y. So whatever it is that's coefficient of the y, that's what I need to take out as a common factor, and let the rest of it work out as it may. X plus 3 squared. So the negative 8 will go on the outside of it because I'm taking out that common factor. And here I have plus divided by minus, so it's going to be a negative 1. So now in this case, we have the same information we need. We have h and k. And we have that negative 8 equals 4p. So I would divide by 4, so p would be negative 2. And what that tells me, think about where we go with this. Although I wouldn't necessarily plan to always graph it, I'm going to do that real quick here, because I have negative 3 and positive 1. But I know that p now is negative 2. So the focus point is going to be going down 2, 1 and 2. I'm going to go to here from focus point. And the latus rectum is 4p. Okay. Does that work? If the latus rectum is 4p and that's already negative 8 here,